Buongiorno tutti. So the presentation will be in English, so it's only 30 minutes at least, so keep up. Okay, so my name is Felix Gomez. I work in Aria Technologies, which is the little sister of AriaNet in Paris. And today, Laurent Maquet and I are going to present several projects led into the last year in Aria. And Laurent is going to present some fluid dynamic applications. And then I'm going to present two projects with PMSS, so parallel Microswift and Microscale. Hope you enjoy.
Okay, so hi everybody. Thanks a lot to AriaNet to enable us to have this pitch. So let's going through CFD application we made last year. So this is the outline of our presentation. And let's start with a few words about Code Saturn. This is a free open source CFD model. When you already know that PMSS is 80% of the solution in only 1% of CPU time. And sometimes we need to have a full CFD model to tackle the customer problem. And Code Saturn does have several turbulence model and physical module, and especially atmospheric flow. So Aria Technologies develops features and carry out specific study for outdoor and indoor application. So let's start with a fire smoke dispersion. It's an incineratory facility in the neighborhood of Paris. Our customer wanted us to train him on Code Saturn, and we help him to set up the case and train him on the mesh grid tool. And this is the mesh of our customer, so now he's better than us on mesh grid application, so we're very proud of him. This facility here, you have some trucks entering the facility. Here there are some openings or closing sometimes, and they wanted to know how if a truck in the facility is burning, how the fire smoke plume will disperse in the warehouse. This is the truck with a high temperature, and we help him to take into account a radiative transfer. So this is you have a very strong plume rise here, of course, in the top of the truck. We perform the simulation on 12 cores, 2040 seconds for 150 iterations. And we use a variable time step to accelerate the convergence. So the time step vary between these two values, so there is a big gap between the minimum time step and the maximum one. This is an application we perform in an industrial site in Belgium. It's a wet plume dispersion. The customer, wanted to know if wet plume will reach the top of the targeted building here. So to address this problem, we first did a little meteorological study to set up the penalizing condition. This is a diagram, it's the temperature against relative humidity. And here the colored area represents the number of cases contained in this value. So if I'm here, I'm sure that 95% of my cases will be better than the one I will simulate. So for example, here we have a relative humidity up to 95% and a temperature which is more or less minus 1.5 degree. So we took the threshold of the wet plume visibility. LWC is liquid water contained. To be visible, the wet plume has to be greater than this value. It's the weight of the water vapor, total liquid water vapor, sorry. And this is the weight of air, the total air. 12 cores to simulate the simulation, 1 hour and 10 minutes for 500 iteration. And these are some outputs of this study. So this is for stable condition, and the wet plume is very tight, as you can see here. This was a study, a dust dispersion nelle Alpi for a quarry in French Alps. This study was very interesting because, as you can see, you have a very high complex topography, and to reach the convergence in a CFD model in such condition is not so easy. We are still waiting to perform the mesh. Another thing which was very interesting in this study is we get a GeoTIFF for the topography, and we get a tool, a free tool, which converts it in S.R.L format, which is suited to the mesher, and compute a mesh for Code Saturn. And this is the wind field, and we are still waiting for the source term emission for 8 months. And this is the wind field obtained. This is a terrain following slice at 10 meters. Another one study was a study on the wind exposure in Charles de Gaulle Airport in Paris. We did it for Artelia, and in fact it was a study for postal package transporter. The study aimed at optimize the base place of windbreak barrier. Here is the computational domain, and this is the interest zone of interest, sorry. And here, without barrier, you have a wind coming from the northeast, and in the zone you have postal packages which are very heavy, and sometimes under strong winds they fly away and they may strike operators who are working there. So this study was to tackle a security problem for operators on this site. So this is with barrier and without barrier. So you can see that the windbreak barrier make a very significant reduction of the wind module. We also performed some rocket launch dispersion for CNES, the French Spatial Agency, in French Guyana. More or less for 15 years, every time a rocket is launched in French Guyana, they run SARIM, which is a very simple soft, which compute the stabilized cloud after the launch of the rocket, and it disperses the wet plume with analytical formula, which are very simple. And now we are building the new SARIM code, and we want to integrate maybe Code Saturn, maybe SkipUp, and maybe PMSS in the new software. So we are going to make intercomparison between SkipUp, PMSS, and Code Saturn, and these are the first result of a comparison between Code Saturn and SkipUp. these are map of HCL release, and we try to define the best test case to compare all the three models. And to end with my presentation, a study it's an air traffic it's an air traffic application, sorry. And the Vinci is construct buildings. It's a big company in France, and to win the contract, they wanted to add some nice picture to enhance the depolluting solution system they will install in Aria in Paris. So the traffic flow emission were computed by thanks Traffic 5. We took into account NOx, PM10, PM2.5, and benzene. And the depolluting solution were city trees, ionization filter, and concrete to absorb pollutants. And we performed simulations with and without, with the depollution system and without, to see the effects. It was a marketing study, but it's always interesting to integrate some this type of solution in a CFD model. And these are the mainly parameters, numerical parameters we used for the study. Thank you for your attention, and I will, if you have any question, don't hesitate.
Okay, thank you, Laurent, for your presentation. So now we're going to switch to PMSS applications, so parallel microswift and microspray. Just take. Okay, so the first application I'm going to describe today is a project we made with Valeo, which is an automotive supplier for automakers. So they are building facilities for the cars, such as comfort and driving assistance, powertrain, visibility, thermal systems inside cars. And for the special event of the Mondial Paris Motor Show in last October, they wanted to promote a new device they are proposing for their cars. It's an air quality sensor inside the car that could help regulating the indoor system based on the air pollution outside. So the team in Aria who worked on this Valeo project was Claude de Rogna, the technical manager, Laurent Maquet, who now you know Laurent Maquet. He did the PMSS simulation over Paris. Marcia is a paid PhD student, and she worked in data simulation. And Viet is a colleague, a research and developer for web services. So the goal of the Valeo project was to propose live air quality system, a map, interactive map of air quality system with high resolution. And on this map, we would see the results in real time of the air quality sensor network. And this sensor would be integrated in the results of the modeling. So we had 2 partners. Of course, we were working with Valeo, and they were sending us in real time the sensor data. This sensor data was integrated in our model. And we were also working with Air, which is the local air agency in Île-de-France. And every day, every night, they were sending us the meteorological provisions with WRF, and they were also providing emissions estimations. So with the network of sensors, the emissions, and the meteorology of Air Paris, we were modeling with PMSS a forecast of the air quality for the next day, and integrating the data from the sensors to publish a real-time map service during the event of the Mondial Motor in Paris. So technically, this interactive map is live, and it's refreshed using data coming from sensors every minute. So every minute we receive a sample of data coming from all taxis equipped with air quality sensors, and this data is displayed on the map. So 1 minute and 10 seconds after that, we check the data. We have a system that is checking if the GPS sensor was good enough to display the data. And then we have, during 10 minutes, a data assimilation of the sensors to correct the modelization of PMSS according to the raw value of the data collected by the taxi. So normally, the map should be still available. So today we are quite lucky because it seems like the air quality is quite nice. So we have a lot of holes into the map, which is good, but not very good for an explanation. Okay, so that was the live system we designed for the Mondial of the Motor Show in Paris. We have some taxis also. So that's the data collected by the taxi driving in this road. So we have 1 minute delay because we need to get the data and check if the GPS is good enough to display the data. And we have the trace of the air quality system that is monitoring the air quality in that street. And the map of the PMSS model is corrected based on the data we are getting from the taxi. Okay, so that was the Valeo project. Now I'm going to talk about a second project, which is a request from the city of Monaco. They wanted to have an estimation of their annually air quality on Monaco. And basically the idea of this project, it's a first step before maybe in this year, a real-time air quality system, live air quality system. But they wanted a first study to check if we were able to model properly the air quality. And in this project, we have compared results of the model versus experimental data collected on the year of 2017. So on this project, Christophe Mahé was the project manager. Anne-Sophie, one of my colleagues, helped me designing. She's a study engineer. She helped me designing the emissions and the post-treatment of the results using GIS tools. And I made the simulation over the city of Monaco. So as I said, the objective of this project is to check the feasibility of a real-time air quality system. We had to make an entire comparison between measurements and model data and measurements. And this map the goal of this map is to show that it's feasible to have a real-time system. So for this project, we are using both PSwift for the estimation of the micrometeorology and PSpray to estimate the dispersion of pollutants coming from the traffic. For the micrometeorology, we had one small surface station that we are using to guess the orientation of the wind and the wind speeds for each hour. And this data is extrapolated in vertical. And this is just one example of the result of PSwift. The domain is quite large, so it's divided in subdomains, in tiles, and this is just one tile representing the wind fields close to the ground. Sorry. The second part is PSpray, so we are using the meteorology computed by PSwift to perform a dispersion on the domain. And we are using emissions coming from Atmosud, which is the regional air quality agency working in the southeast of France. So they gave us emission data along those streets. And they gave us also the results of live air quality stations that are inside Monaco. And this helped us designing the background noise of pollution inside the streets. So this is the typical 1 hour average concentration of NO2 on the city of Monaco. And with this data, we performed 1 year of simulation. So the domain is quite large. It's 3.5 times 4.5 kilometers, squared kilometers. We are at high resolution with 3 meters. We have 6 subdomains. We have a vast number of sources. We are using quite a raw emission time step because we need to perform 1 year of simulation on a vast domain. So it's we have an emission time step of 10 seconds and simulation time step of 5 seconds. And we provide results by hour, so it's 1 hour averaging. We are making a dispersion of all these species, and we are considering chemistry, equilibrium between NOxes to have a better estimation of NO2. This chemistry model is Chapman in steady state form. And we had the occasion to use a large cluster for this simulation, so we had 144 cores, and basically the average time for Swift is 15 minutes for 1 day, and the average time for spray is 2 hours per day. This is the typical results we had on a daily basis. So these are 3 traffic stations. You have the result of the model in red, the result of the station by hour in black, and the curve in blue correspond to the background we are introducing in the model to correct the background noise. So this is a result by hour, and this is the typical map of concentration you get per day. So it's a 1 day average. This is 1 hour average, and this is 1 day average concentration of NO2. Unfortunately, I cannot show you the final results of the 1 year of simulation because we're still working on the delivery for the customer, and we want the customer to have the exclusivity of the results for the moment. Thank you for your attention. If you have any questions en français ou en anglais.
Molto interessante, Felix. Thank you.
Yeah, I have a question for you about the study that you made for Paris Motor Show. On Paris, you had a number of cars equipped with sensor on board, and it was a demo. So how many you had at that moment? And if I well understood, you are planning to extend that for the future, right? So how many?
Yeah, we had up to, I think it's 20, around 20 taxi working on the city during the events. For the special event, they wanted to have lots of taxis, so there were guys driving without clients just to make the air quality show. It was not good for air quality. Yes, so we want to keep this system live, but it's up to the client because we are working on a cluster and we have to pay for the simulation costs. And we are still discussing with Valeo if they want to keep this live because it's a good promotion for them also to see that they are working on this.